Okay. Hi, everyone. I'm Lindsay. I'm going to be talking about my joint work with Professor Rohan Alexander on the digitization of the Australian Parliamentary Debates. So I want to start out by defining Hansard. So the Hansard is the traditional name for the official written record of everything said in Parliament in Australia, the parliamentary debates. And the concept of Hansard originated in the British Parliament, and it's remained tradition in many Commonwealth countries, so including obviously Australia, the UK, and Canada. The Hansard reports capture all parliamentary proceedings, and they're essentially but not entirely verbatim. And there are people called like Hansard editors who sit in on the proceedings and record everything as it happens. And so that's how they're made available to us. And for Australia, this has been done since 1901 to the present day. And so obviously you can imagine the content and magnitude of these records is very large. And so they're super valuable and a really good resource, especially for political science research. So we are going to dig into this. So I just want to give you some background on the Australian Parliament. So similar to Canada, Australia has a bicameral system where the lower house is the House of Representatives and the upper house is the Senate. In our work, we focus specifically on the House of Representatives. You might hear me just refer to that as the House or the House of Reps. The House of Reps performs a number of really important functions in government, including overseeing government expenditure and creating new laws. So there is something called a parallel chamber set up within the House, and that just basically means there are two debate venues in which the proceedings take place. One is called the chamber, that's the main debate venue, and the second one is called the Federation Chamber, and that is a subordinate debate venue where less controversial proceedings take place. That was established in 1994, largely as a way to like better manage the time of the House, because there's just so much happening in these proceedings. So they kind of defer the less controversial matters to the Federation Chamber, such as like intermediate stages of bill development, for example. And there is an elected speaker and deputy speaker of the House. The speaker takes the chair in the chamber, that main debate venue, and the deputy speaker takes the chair of the Federation Chamber proceedings. So don't worry about reading everything on the screen. I just wanted to include this to give you a visual of what a typical sitting day looks like in the House. So on the left, we have the order of business for the chamber. On the right, the same for the Federation Chamber. These infographics were taken off the Parliament of Australia website, and they basically lay out the schedule for every single sitting day in the House. So you'll see that like there's 4 sitting days a week. The proceedings of the chamber and the Federation Chamber happen simultaneously. That's why I would call it that parallel chamber setup. And I just want to like illustrate that there's so many components that go into each sitting day. And like I said, the scope of business in the Federation Chamber is much narrower. So that's why there are like a lot more gaps in the schedule. That's what we would expect. So now that you know what Hansard is, you might be wondering like in what form is it actually available to us? So about a week or so after each sitting day, a transcript for the Hansard from that sitting day is uploaded to the Parliament website in 2 forms. So the first form is the static PDF, and that's like the official release. And the second form is extensible markup language, or XML. And the PDF is converted to XML using something called optical character recognition technology. And so the static PDF is designed obviously for human readability, but the XML is interesting in that it's designed for machine legibility. And so it gives us a lot more opportunity to work with it at a greater scale with code. And so I'm just gonna like give you a sense of what's happening here. If you haven't seen XML before, the first time I looked at it, I was like freaked out. So it's basically a series of nested elements, and each element serves as like essentially a container for some part of the data in that document. And there's like a hierarchy going on in the way that things are nested. So that's how it works. Like I said, every set of nodes is like a container for some part of the data. And I also just wanted to say that the way that Hansard exists right now is not really usable for like large scale text analysis purposes, because this is how it looks and it's hard to work with any of these things, obviously. So we're trying to essentially bridge that gap. So that leads me into what our end goal is. We want to create a publicly available database containing one CSV file for every sitting day of Hansard from the 1901 to the present day. And to this point, there doesn't exist a comprehensive database like this that's based on the XML. So that's what we're doing. We do it all using R. We want each CSV to contain everything recorded, where every single statement is on its own row, and all statements have the correct timestamp, page number, speaker details, all of that. And then we also want to make sure that there are a bunch of added variables in each CSV so that it's easier for people, depending on their research interest, to navigate through the statement. So for example, we added a bunch of flags so you can filter out the questions and the answers if that's what you're interested in. I also do want to mention that this has been done for Canada. So a team of researchers at U of T have done this for the Canadian Hansard. It's called the LIPOD project. So we're really like following in their footsteps in our work with Australia, and there's a link if you're interested. So what have we done so far? We have successfully done this for about 11 years. So currently we have around 670 CSVs made. This is what they look like. So like I said, every row is an individual statement with all of the correct details on who is speaking. And then all of these binary flags as well. So like I said, questions and answers, you can like sort through things much easier. And we are working on updating the scripts so that we can work further back in time. And the reason that we haven't worked further back in time to this point is because the structural formatting of the XML has just changed so much that the code doesn't work for it. So we're working on that. So here's like a high level overview of the method. So to start out, we selected a single XML and just worked through it. We wanted to understand the structure that we're working with, that hierarchy of elements that I was talking about, just the way that things are stored. It's really important to understand that, because the way you approach XML to parse it is like entirely based on that tree structure. So that's how we started out. Once we understood what we were working with, we could then write the code to actually parse all of those things. We use the XML package in R to do that. And then once we had everything, we could actually put it all together. So we developed a script that would do that chronologically, separate all the statements onto their own rows, clean everything up, fill in the data, all of that, which I'll get into in a few slides. This was probably like the biggest part of the project. And then once we did that, this was all just for one sitting day. So we had to generalize and work backwards and keep adding to the scripts that it worked for as many sitting days as possible. Okay, so before I actually show you what the XML looks like, I wanted to show it in a way that's a little bit like easier to look at. So this is sort of like a skeleton structure for what you'd expect in a typical Hansard XML. So starting at the top, and recall that I said that each node is like a container for some part of the data. So the Hansard node at the very top, that would be called the parent node, that contains absolutely everything in the document. So the very last line would be that node closing. Working in, we have 4 child nodes, so 1, 2, 3, 4. The first one is the session header. The second one is the chamber.x script, and that's everything that happens in that main debate venue, the chamber. The Federation Chamber X script, same idea for the Federation Chamber, and then answers to questions. So as you can see, there's a lot going on. I just want to draw your attention to the debate node, so B. That is pretty much like where the meat is that we're trying to get at. The proceedings in the chamber and Federation Chamber are like a series of these debates. And within each debate, there are other sub-debates, there are other speeches going on. So that's really how it works. Like it's just a series of these debates. And within each debate and sub-debate, there's a speech. That's like where obviously the speeches are. And I did want to also point out that within the speech, it's not just like a nice clean body of text. There's a lot of things happening in the speech. There's interruptions, continuations, questions, answers, comments. There's a lot going on, as you would expect in in an organic, like human conversation, but these things are all transcribed differently. So we really did have to like account for all of those things. Like I said, same idea for the Federation Chamber. And the last thing I want to talk about is this answers to questions child node. So one component of every sitting day is something called question time. And that's a time when ministers or members can ask ministers questions. And it's really an interesting part of the day. And so there's two types of questions that can be asked. One is a question without notice. That's just asked during a speech. They have time to do it. In the moment, they can ask the minister and the minister will respond in real time. That's what would be transcribed here as like a question or an answer in a speech. There's a second type of question that can be asked, and that's a question in writing. Those are asked in advance in writing. The answer is also provided in advance. And so those would be transcribed in that very last node there. So just so you know what we're working with, now I'll give you some actual examples. So we added some color so it's a bit easier to like look at and digest what's going on. But like I said, that very top parent node is Hansard. That's the container for everything going on in the document. Working in, we have that session header. There's a bunch of sub children, that's like the terminology for it, with all this information on the sitting day. And then that closes up and the chamber X script node opens up, and that's where the chamber proceedings are captured. Every proceeding starts with a business start. That's highlighted in green. And what we highlighted in orange is what we're actually trying to grab. So from all of this, we really just care about what's highlighted. So I'm going to show you the code for how we would actually grab this. So here's the code. I want to just draw your attention to this box here in black. This is called the X path, and this specifies like the node path, what you're telling the function to go look for what you want in the XML document. So this was really important. Like we want the chamber business start, so you just specify that. We use this get node set function from the XML package. And you have, that gets you what you want. It's just not in a really nice form. So all of this code is us formatting it so that it looks like this. So it's tidy. We correct the variable classes. We extract the day of the week, the date, and the start time, so that we just really have as much as we can get out of this bit of text. And you might be wondering why, like, you see my cursor? Yeah. We have these if-else statements. And that's because sometimes the nodes are just named different things depending on the year. So we just like, this is something that we developed as we worked through the sitting days. This is just our way of accounting for the structural variation over time. And you'll notice also we have this bigger, like everything is wrapped in an if-else statement. And that's because we really want to make sure that what we're trying to parse exists in the document. Otherwise the code will break. So there was like one rare day in those 11 years where there wasn't a business start for whatever reason. So we just want to make sure the code is not going to break. So that's how we approach this. And you can see we use a lot of regular expressions to extract things. That was like a huge part of this whole project, regular expressions. Here's another example. So this is how we would parse a debate. So like I said, proceedings are a series of debates. Here's one. In the screenshot, the parent node is the debate in yellow. This is everything within that debate. You'll also notice the speech. So there's a lot of information here. I'm going to show you how we would parse this, as well as the information on the speaker. So yeah, again, you can really see like there's so many nested elements. There's a lot going on. So we really had to understand what we wanted and how to organize that correctly. So this would be how we would grab the debate. Again, we specify the X path. We want the information on who's speaking and we want the speech. And it comes out in this nice tidy table format. We were able to extract the timestamp from the body of the text and just tidy everything up, clean up any spacing issues. Again, all with regular expressions. And again, everything's wrapped in an if-else statement because not every day is going to have every single element, and we just really want to make sure the code is going to work. Oh, and also it's the same idea for the Federation Chamber. It's like the exact same thing. So now that you've seen a couple examples, before I get into the next steps, I did want to highlight one bit of the parsing process that was tricky, and that was that question time process that I mentioned. So like I said, it's a time when members can ask ministers questions. Two types of questions, the questions in writing and the questions without notice. It's a really important time of the sitting day because it allows the executive government to be held accountable for their decisions. But this was tricky. So the thing with the questions in writing is that there's no timestamp associated with that. So they're all NA. And that was hard because the page numbers are often the same for a lot of these things. So it was really tricky to make sure we were maintaining the right ordering of things. There was a lot of different rows that we were merging together. So that was tricky. And we sorted that out by mapping the questions and answers and merging them in such a way that every question was followed by the answer. The other tricky bit was that sometimes answers were nested under the question node and vice versa. This was something we realized as we went on because we expected that every question should be followed by one answer. And we saw that sometimes this wasn't the case. And we realized it's because sometimes things are just not nested right by in the XML. So you can see what I've parsed here, the X path specifies the question node, but we do get an answer. So we had to manually use regular expressions to match when you find the answer, recode it so it's not flagged as a question. Okay, so we've parsed everything, looks good. Now what? Well, there's actually there's a lot more. So this is just one line. If you look at speech number 5, at the very end, there's actually over 20 different statements embedded within that single body. So the next big challenge was actually splitting all of these things out. There's a lot going on. We also had to fill in the name ID, electorate, and party stuff. That didn't just come when we split the rows out. We had to fill all that in. So this is the fun part. Yeah. So I'm going to give you another example that's a bit shorter. So like I said, raw text data were not separated by row when we parsed them. It was just one giant string of text. And like I said, there's a lot going on in each speech. There's interruptions, continuations, all that. And that was just one big string. So we wanted to split that out. Here's an example. It's a short body. This is the beginning of a speech. Mr. Andrews starts to talk. Mr. Martin Ferguson interrupts him. Then he continues. The deputy speaker pipes in, and then Mr. Martin Ferguson interjects again. So we want all of these things onto their own lines. And I'm going to show you how we did that. So first thing we added was a speech number variable. And the reason we did that is because that way, as we split out the rows, we would have this consistent number. So we could keep track of what interjection that belonged to in terms of what speech it belonged to. So we wanted to be able to group by speech, basically. So once we did that, we needed to actually extract all the names and titles preceding those interjections so that we could then look in the text and know where to split the text. So this required us to think to consider all possible forms in which these names and interjections could be transcribed. So we could look for the right spot. And so we approached this by building a master list of regular expressions of all the member names in every possible form they could take. And so here's an example of just one name. It could be transcribed in a ton of different forms. The capitalization can change, the completeness of the name can change. You can only imagine what a nightmare it was for people with 3 first names and 2 last names, and it was a lot. So we had to do that. We had to build that list. So here on the top is an example of the beginning of one of those lists. We want every name, paste it in a unique form in which it might be transcribed somewhere in the text. For context, this one was about 450 names or forms. So there's a lot of names and a lot of variations in transcription, which made it tricky for us. But once we made that list, we could then go back and extract any matches for names in the body. And so we actually came out with 57 matches. So this really narrowed things down for us. And you'll also notice that we pasted in possible prefixes. And that's because for interjections, people are transcribed Mr. Ferguson interjecting, for example, there's like usually that prefix. So we wanted to extract that. And then we use this regular expression look ahead to make sure that that name was followed by a space or a punctuation. Yeah. So now that we had all of our matches, we could actually split out the rows. And this was like a whole other thing. I don't have time. I don't want to like go into the whole thing, but there was like a lot of different steps into splitting up the rows, because sometimes like members would just like name another member in their speech, and we don't want to split those up, right? So we really had to be careful, use a lot of those regular expression like look ahead, look behind, to specify where we were splitting things. And once we did, we could then actually fill in the correct full name, name ID, electorate, and party, because again, we want this data set to be as complete as possible. So we created a lookup table, and we did that using all of the names and the information we could get from the XML, and then also the Australian politicians package, it's Rowan's package. And we use specifically the gender and unique ID from this package. And so we created this lookup table, and then we merged it with our main data frame and filled in the complete name and all the speaker details. So the last thing we actually had to separate out from the text was something called stage directions. And stage directions are basically transcriptions that aren't like explicitly said in the parliament. They're just kind of documenting the happening. So for example, like debate adjourned, or like there's an interruption in the debate. Nobody explicitly said that, but the Hansard editors will put that in just so like we know what's happening. And so we built a list of these stage directions manually, and we wanted to separate these out. You can also see that we used a bunch of like these regular expression patterns, so that it was generalizable, and we could like, you know, anytime we were able to split that out. Yeah. And we just split these out and gave them the name stage direction for consistency. And so the last step, we wanted to flag for interjections. So we had all the statements on their own rows, but we wanted to add a flag to identify like where the interruptions are happening. And so I just bring this example back so I can show you how we defined what an interjection was. So we grouped our data by that speech number variable. Like I said, we wanted to keep track of like everything happening in each individual speech. And then we defined an interjection as a statement made by anyone who is not the elected speaker, the deputy speaker, or the member whose turn it was to speak. So in this case, it would just be Mr. Martin Ferguson who's being flagged as an interjection. Yeah, and then we have that binary flag for interjections. So I'm going to finish off with some descriptive stats. So it was fun to dig into the data a little bit after all of this. And so what you have here on the left is the daily number of unique names. And so you can see that there's a lot more per day for the House of Reps or the chamber, like the main debate venue, compared to the Federation chamber. And that's to be expected because there's a lot more happening in the main debate venue. But you can imagine, like with like 80 names per day, there like those regular expression lists were so much. We had to account for like so many different types of names and like punctuation in names and stuff like that. And then on the right, we have the CSV word count over time. Just for fun, you can see obviously we expect the word count for the Federation chamber to be a lot lower because there's just not as much happening. And then the last set of plots I wanted to show you is we computed the percentage of statements that are flagged as interjections by gender. And take it with a grain of salt because there are a bunch of interjections that are made by like general members. For example, it will just say like an honorable member interjecting. So we can't like attribute a gender to those, but from the ones where we did have a gender, this is what we got. It's interesting to see that the male interjections seem a bit more consistent over time, especially in the House of Reps. There's a lot more variation with women. We don't know, we haven't dug into exactly why this is happening, but it's definitely really interesting and something that we want to explore. And I'll just finish up with the next steps. So obviously we want to keep working back in time. We need to keep developing our scripts to make sure that we can parse as far back in time as possible. I also want to put some more work into revising that name matching code, because just because of the complexity of like the name matching process, there were some names that like maybe weren't perfectly matched and we couldn't get the gender right or something like that. So that's something that we want to do in the future, just to like maximize the completeness of the data set. Obviously make the data set publicly available so that people can use it, and then like dig into the data a bit more. I mean, we started with these descriptive stats, but I think this data set offers like a lot that can be explored. And it would be interesting to see what questions might come up as we look into it. So thank you.